So they say we have an array of cells. So cells one after another. We start at one cell and we can move. How do we move? With those two commands, arrows, you can say. So with this, we move to the cell to the left, and with this one, we move to the cell to the right. And once we are in a cell, we can either increment the number of the cell, which goes from 0 to 256, 255, sorry, and it overflows. So if it's at 255 and we add 1, it goes back to 0. So we're at 0 and we subtract 1 with the minus, it goes back, it goes up to 255. And we also have these brackets that works as a loop. So whatever is inside here, let's say we add, it's going to do it. So this, for example, would keep adding to the current cell, and that will repeat itself up until the value of the current cell is 0. And what would that happen? You could think never, because if it keeps adding, it's going to keep getting larger. But I just say it overflows, so it's going to add. It's going 1, 2, 3, 100, 150, 200, 250, 251, 252, 253, 254, 255, and you would welcome next 0. So then it will halt this little segment. It will go out of the loop. And then what could we do? Well, we will still be out of the loop, so I think it was the dot that printed it. Let's see, yes, the dot prints to the screen, and
character input from the key.
the comma takes an input. So we've got it here. We could do what I just did and go through it ourselves, like thinking it through, but I'm not going to do that. I'm too lazy for that. So we're going to go here to the comments where a good human just left us a BrainF interpreter. But we can just go, open, and let's try. So we have this. We said we started at 0. And after starting at 0, on the same cell, we enter this loop. And this loop increments. It increments infinitely. But the loop stops when the cell has a 0. So out of here we should have 0 again on our cell, and we could print it. And we printed this stuff, which I believe it's an ASCII character for 0. This 0 is ASCII character. So that's the thing. This thing brings ASCII characters, not the number that is here. So we can go here and search an ASCII table. What's an ASCII table? What's ASCII? Well, ASCII is just let's say, it's a way to map numbers from 0 to 255 to a certain set of characters and symbols. So let's say here we have an ASCII table. We're going to place it here. New file. Here, a pretty ASCII table. So what do we have at 0? We have null character. So how can I see what character is this? Let's see if we can inspect element. Text area ID. So what's inside? And now there's seems to be no character in there. So What if we add 1 to this before printing this? So it's not an odd character. Well, no. Let's try adding. So what is a number? Or something printable. We have the 33. It's an actual character, so let's start. We start at 0. We go 1, 2, 3, 4, 5, 6, 7, 8, 5. And I'm not going to count because most likely I'm going to mess up, so I'm just going to hold this. Yeah, I think we're into the printable characters. So run code. And we got to print. No, that's not a printable character. Maybe we went too far. Yes, we've got a K. But we don't know how many how many plazas there are here, so what can we do? We can't count them, but I don't want to count them. So I'm going to use Python. Yes. I'm going to use Python. And I'm going to generate a string which I know has exactly, let's see, what do we want? We want an A, and that's 65, which has exactly 65 plus symbols. So we'll have 1 plus symbol times 65. Yes, here we have. This is a pretty string of 65 plus symbols. And we're going to paste it here, and we should get as output an A. That's great. So we know our program starts like this. It starts at one single cell, and that cell is valued at 0. Then we increment. We keep incrementing because this is a loop, but we can't increment forever because because the cells will overflow and go back to 0. But what if we add a number that is not divisible by 256? Let's see. What number? Let's try 7. Is it? No. Let's try with 7. So there are 7. And this in theory should not halt. It should stay in a loop. Well, it says it's finished. What if we print? It should print this thing. Is there another better BrainF interpreter which tells me which decimal character? Let's see. Type in BrainF interpreter. Program code. Oh, this one is much nicer. This, yeah, length program. We have a plus and then we print. So others, but okay, this is our array. Step, no, run. Oh, so we can run it step by step. Hey, this one is cool. So let's go back. Yes, we've got. Let's try our previous one with 7 and see what's happened. So we're going to step. Oh, it never goes in because at the beginning the current cell is 0. It doesn't go in. So it goes through the loop, but it doesn't get in because it's while the current cell is 0. But on the first iteration the current cell is 0, so it never goes into the loop. Okay, so let's try adding a plus first. Okay, we add a plus. We end up at 0. Executed 587. So after 587 it holds. Yes. It must be when, let's see, that number must be divisible by uh, hmm, let's see, 587 steps. So that's the amount it added. Executed, yes, executed 587 instruction. So that's, let's see, we have 256 times 2 times 2, 255 times 2. This is not divisible by 7. Let's try running it step by step. Step. So, oh, I have to run 8. Oh, let's click. Let's just keep clicking. Let's see. We're up to 43. And this made a lot of, like, 500. So, oh, let's just hope that I don't get carpal tunnel from this. If I edit this later into a video in YouTube, I'm probably making this bit a little shorter. Let's see. We're 170. Let's go faster. 200. Let's click with 2. No, clicking with 2 fingers is not effective. Let's switch to the other finger. Uh, let's switch fingers. Oh, and there are more instructions. See, we're up to 51, 241, and we have executed 276. So we executed 1 at the beginning. 1, not 7. And then we've got the loop. That's, let's say there are 7 instructions of adding and 1 instruction of looping, and we've looped 200 and, well, I don't know how much we've looped. 200, let's see, let's step. So let's say we've looped around, let's try 30 loops. We're more than 30, 35. Yeah, about 35 loops we've done. So It would be awesome if I could just loop through the whole step through the whole loop. So we're 254, 255, and now we're back at 0. But we start, let's see, this will be here and 0. This would be where we started. Let's say, when we first started, we started with a 1. We got into the loop with a 1. That got us in, and this position would be this one. And we finish, yes, we finish here. Let's say here we had 0. But if we start here, we do 1, 2, 3, and we're going to start to finish 4 later than when we started. So we would end up at 0 here. So let's see, this position will be this one. Hmm. So let's assume I'm going to run to this instruction. Let's switch fingers. Let's switch hands. Oh, let's go. My mouse is suffering. Let's go 180. We're near. We're near. We are near. I need a better debugger for this thing. One debugger that will not make me break my mouse. 251. Step. And yes, this final add brings us to 0. 0, we reach the end of the loop. We go back at the beginning of the loop. And yes, we exit the loop because it was 0. So now my question is, with any number that we put here, I know this is a basic algebra question, but with any number that we put here, can we eventually reach yeah, it would be a multiple of of 255 offset by 1, let's say. So we're at 7 times synthesis. After 255 loops, 55 and 56. See, 255 times 2, it's 530. And we have 7 times 80, 560, 75, 25. 76, 32, the closest number. 5 is 72 loops. So we add 1. Well, this is why it's called BrainF. Fucks with your brains. Yeah, basic maths fucks with my brain. Let's change. Let's do hello world now. We've tried this little program, so let's now do hello world. Let's make a pause and edit my stream info, so it's now I'm just doing this in English. Let's remove the Spanish. And for anyone that comes in, we're going to put the message so it stays there on the message board. And let's say, hey, if you just got here, feel free to say hi, and I'll go over, say hi, and I'll go over what I've been doing. Okay, and way too slow to type, it seems. Okay, so we had this program. Now let's do hello world. We're going to do it in a way that's the easy way. We're going to our ASCII table, and which is the age? Age is 72, so we're going back, we're getting 72 plus numbers, plus symbols. We're going to print them at the beginning, and we've got an age, and then we need an E, which is at 101, and we're not going to switch cells just yet. That's later. We are going to try to first go through the cells and store the letter in each one of the cells, or better said, the number associated with the ASCII character. We're going to go through all of them, then we're going to loop back until we're at the beginning, and then we're going to loop forward, printing each one. So let's see. We're here at the edge, which is 72, and we want to get to 101. We do basic math, and we get that's 29. We need 29, or I have an off by one error in my maths. No. Control Shift. The console is kind of annoying because Control C is mapped to closing the current program. Well, this IPython allows me to press it once without closing, but to copy and paste you have to use Control Shift C and Control Shift P respectively. So, yeah, we got he. Now we need an L, which is 108. 108 minus, no, it's the other way around. No, it's 108 minus 101, which is 7. I don't need my calculator for that. And one dot and two dots because it's two L's, so we don't have to change anything. Now we've got hell, which is what programming in BrainF feels like. Okay, hello. And for that we add 3 more plus, and we got hello. But now we need a white space. We need a space. And we got to go all the way back to 32 in our ASCII table, which just now I'm realizing you can't see very much of it in the stream. So let's see. If I edit this later, I'm going to have to. Okay, so here it is, the table. I hope it's, as you can see, it's for the YouTube video later. I'm going to have to put this greater on screen. So we've got hello, and we've got to go from where we were. That was the 111 back to 33. So 111 minus. So that's 78 minus sign. So we got times 78. We add this, and we're going to get a space. No, off one by one error. Now we've got the exclamation sign, which is one after. So yes, we're at 21 now, and 20. I'm sorry. Now we need a word. We need a W to say hello world. Sawordo. Hello. Oh no. So 87. I'm going to do math in IPython, I believe. It's less one-sided than me using the calculator, unless you can see it. So we're at 32. 55. We need 55 plus symbols. 55. Hello, W. We're making some progress. Now we need an O, 111. So 111 minus 55, it's 56. No, I somehow fucked up. Oh, 55. 86. 87. Oh, 24. Let's see. I have a feeling that this last one is wrong, but yeah, no, it's right. Hello world. So R. Next one. So 1, 2, 3. World. 7. One extra. World. And we need a D. We're at L, so 1, 2, 3, 4. 1, 2, 3, 4. Hello world. And now, earlier we got the exclamation sign by error, but now let's just get it. Hello world, which is the 173 will be. We need 73 minus signs and 73. or we need yes, that. Oh yeah, 67. Oh, how can I fail that? So yeah, 67, and now we've got Hello World here. This is awful. We're going to save it, but that's Hello World, and it doesn't fit in the editor. So let's make it a bit now. Before we make it larger, now we're going to make it smaller. Yeah, this is Hello World. Let's say Hello World. That's our program. Now we're going to do what? Hello World 2.0. A better Hello World. We're going to create a better world. So what are we going to do? First, we are going to store each value in a cell. So we're going to start at th. Where is th? In this table here, 48. So we start with 48. Start with 48, I say. Then what do? We go to the next cell and to the 101. There, HE, next cell. Now L, 108. This is more code, but it's easier to write. It's about like a more brute force approach. So now we would have hell. Now we have hell again. And oh, 111. Low 32. 40 space. This is getting really long. 32. Okay, now world, which 87. 87. Oh, 111. War R 114. Imagine if I were to do this by hand. It would be the entire stream just typing hello world. L and D world 100. And we end up on 33, which is the exclamation sign. Now, we've successfully inputted a string. a string that says hello world in ASCII characters. So what do we want to do now? Go to the next character. No, we're at the last character of this string. So now we're going to start a loop. Inside this loop, we're going to loop and we're going to go back. We're going to go back until we're at 0. And that will be the cell, the first cell. I don't know if this goes, let's say when you're at the start, you can go to cells to the left, or if you just can go to the right. So we're going to start on the 0 cell. The 0 cell will be 0, and then we're going to start adding. And then we're going to go back. Just go back to the beginning. This goes back. It's in the last cell. The last cell is non-zero. It's an exclamation sign at 33. It's going to go back, go back, go back, go back, and it will read 0 on the 0th cell. And once it's in the 0th cell, it will go forward once, and then it will go into a loop, print the first letter it encounters, go forward, and loop. Oh, hello! Okay. That's not what I wanted. It's printing world twice. The D twice and a 0. So let's take this to our debugger because I don't want to debug that by hand. And let's just run it. Well, we got, I make a mistake and put to, let's say th was 48, but why did I put, oh, I mistook the hex character by the decimal value. Oh, that's it. Now we've got to go back to our code. Edit code. I'm going to make this larger so it's easier for me to see. So yes, we're going to, the first th is 72. Select the first, there it is, 72, and the D. I guess the last D was extra. Did I paste an extra D? Maybe. Execute, run. Output, hello world. Oh, I know what I did. Yes, I instead of pasting a D, an exclamation sign, I pasted a D. So here it is. Run. Hello world. So this goes to each of the cells. First, adds the number. So we just hard code the number. And then when it's at the end, it goes back up until it finds a 0. And when it finds a 0, then goes to the next one and starts looping until it finds a 0 again. And on that loop, it prints each cell it passes by. So yeah, this is our second version of Hello World. It's a little bit longer, but it was much easier for us to code. And I know it's a bit more complicated, but in a good way, I like to say. See, this one is just this, and this one is all this filled with plus sign. Now we're going to focus on making something a bit shorter. We're going to cheat also, because we're not going to input this manually. Let's say inside, it's not going to be hard coded. So we're going to do hello world, but we're not going to write hello world into program. We're going to make an echo program. We're going to tell something to the program, and the program is going to say it back to us. It's going to print it. So that's our new project. So now, this is the one I hadn't done before, because the other ones I had tried very briefly, but this one is new. So let's take a break with a sip of water. So let's see. We start at a cell with 0. We're going to add 1 because we need to loop. And if we're at 0, we can't loop. We cannot loop. So we're going into the loop. Once we're into the loop, let's see, what do we do once we're into the loop? We want to get a character. Thing is, I don't think we can get a new character. Or yes. Let's see. We're going to get a character. No, we're going to move forward and get a character. Because if we get a character and then move forward, the next cell is going to be empty, and we're not going to be able to continue our loop. So let's just try this simple program, this 5 symbols, and see what it's doing. I wanted to check if my microphone was on. Because that would have been pretty embarrassing, like an hour of the stream speaking muted. Execute. So we're going to step. We go into. We go move to cell. We take input, but we gave it no input. Yeah, it takes nothing. And then it finishes. Great. Now let's add some input. Let's add hello world. And this should store hello world in the cells. So we're going to step in. We're into the loop. We're inside the loop right now. Now we move forward. We read the first input. Yes, 72. 72 was it? TH. What is 72 in ASCII? It's the H. Yes. We probably remember that. So now, back to the loop. Move forward. Read. 101. So yes. Now 32. That's our space. And 33, that's our exclamation sign. We move forward, we read, there isn't anything else to read, and we stop. The program is finished, and this is our input, and our output is nothing. Okay, now what do? We go back to our previous program, copy this, and we go back one because we're at a 0 cell, and we execute this, and we just run it, and we wind up in a negative memory index because this thing. Oh, so now how do we init our initial loop while being at 0? So the 0 cell. Because if we just delete this, the program just won't do anything. Well, let's say it will, yeah, it won't run the first loop. So now, how do we solve this problem? We need this to start. Our program does not allow so maybe this. Or maybe should we let's say later we could override whatever is in the cell and yes, start at the first cell which will have a 1 and override that. So make a loop that's subtracted to 0, subtracts it to 0. No, but let's see. We go forward one. The thing is, now we're using 2 memory spaces to start. But this should work. And it works. Yes, you see, we have 0 and we have 1. With this one, we initialize our loop. And our loop goes forward reading from the input, and then when we run out of input, we go back 1 and start our loop of looping back, looping and going backwards. Then we reach 1, we loop backwards once more, and we reach 0. Where we're at 0, it stops. And then we go forward twice, so 0 to 1, 1 to 72, and then we enter a loop. And where we print the character, we go to the next word, and we loop. We loop until here, where in this loop, we print this character, and we go next to the next, and we go to the next one, and the next one we decide. Do we want to plot to continue? No, we are at a 0 cell, so we do not continue. So yeah, that's an eco program. As you can see, it's much shorter than our previous programs. So let's see, what other program can we do? Hello World 2.0, Echo. Well, I had searched for Hello World. What? Let's see, what does this Hello World? How does this one work? Because this is much shorter. I guess there is some. They try to compress it by looping over this part. So try executing it step by step. So it starts at putting a 10 in the first one. It goes into the loop, moves forward, places a 7, then moves forward, places a 10, and a 3, a 1, and it goes back to the beginning. 10. It repeats. Like the previous number, we multiply them by 2, let's say. An 8. Oh, I understand. So we got this number, which is 10. So it's going to do this 10 times. Yes. Like, so it's like a for loop that iterates 10 times. That's nice. So we start. We say 10. This is how much we want to iterate. And 10, we go, well, we go forward one, we do something. We go forward one, we do something. We do something here. And at the end, we go back how many times, the amount of times we need to reach the index of our counter of, let's say, the I variable. The address 0 is the I variable in a for loop. And we subtract 1. And that's the loop. So this is going to print 10 times this, 10 times this, 10 times this, 10 times this. And I'm going to be a while clicking here if I want to pass this. So let's say it went 10 times. Yes, it did that. So, and then let's say we got 10 times 7, so 70, and they added 2. And when that's 72, and at an 8, we print that. We go to the next one, and we add 1, and we print it. So the next one is, let's see, we're going to get this again, and I'm just going to step over the first loop. Yes, and there we're going 100, because 10 times 10 times 100 and 101, and we got the E. And we print it, and then we advance from the E to the L. This amount of times. Yeah, we print it, and we print it twice. To the O, 3 times. We advance. We add 3, and we end up at the O. Then we go forwards to the 3, 30, 32, that's our space character. 32, that's our space character. We go backward twice, so we were at 3, we go back to the 7, which now was 72. This is BrainF. So just basic arithmetic. 72 we were, and we add this number, which I presume it's the distance between th and between 72 and 87. We print that. We go forward, so to the 10, which now I'm not going to, was another value. We add 3, we print, and then we subtract some numbers, we print, we subtract some numbers again. We print, we add 1, we print, we go forward, and we print. So let's run this, and yes, it does the same. So the last symbol, that it's a 10, no, 100. So what is the last symbol that's printed? Because it's a length of input 12, but output says it's 13. And I'm not going to run with this. Let's see if we just delete this. But that for loop is interesting. Yeah, and this just prints characters which are senseless because okay, let's just move forward and see what's the last character printed or where it landed. So it landed at 4 and printed it. So what did we have at 4 in the previous one? For 10, 11. So what's the 11 ASCII character? A vertical top. Mm, why a vertical top? Well, horizontal top, vertical top. Oh, it's a new line character, a vertical top. Let's see. Vertical top character. No. So which is a new line? Let's see, the new line character. Which one is it? End of, let's see, start of heading, start of text, end of text, end of transmission, inquiry, acknowledge, spell, backspace, line feed, vertical tab, form feed, carrier return, so this is to go back to the beginning. Shift in, data escape, device control 1, 2, 3, 4, negative acknowledge. So, which is the, let's say, the line end? Vertical tabs was used to speed up printer vertical movement. Some printers use special tab belts with various tabs fonts. So it does that. Let's try it out. Printer. Are we going to print hello? We're going to use a vertical tab, which was this world. I didn't know it did that. That's cool. A vertical tab. No, but let's see. What is the ASCII new line? Let's see. End of line. End of line. Line feed. New line. Well, R, I believe did. Let's say. Let's remove this. Let's learn a bit about ASCII. So in Python, we change the end of a string by using this keyword argument. So if we do that, well, this doesn't work pretty well inside IPython. So let's make another tab and use regular Python. If I print here, hi, and I tell it to end it without a new line character, yes, it prints it char. But if I tell it to end with a carriage return, it uses like, oh, what was the carriage return? I did this R and say no. What did we print? No. Okay, so how is this? This ASCII character. When I put it at the end, oh, I know what to do. Yes, it. No. So let's remove this, and now the thing is, we print this. We have this, and we're going to print it. It's going to print these characters. 1, 2, 3, 4, 5, 6 characters. Before we were printing 3. Now we're printing 6. Because we were printing only 3, those 3 were getting overwritten by the 3 things. The 3 spiky things at the beginning of the prompt. And that's because with this character, what this character does is return to the start of the line. So with this longer string, we should be able to see an O and an exclamation sign at the beginning of the prompt. Yes, and we can overwrite them. That gives me an idea. So let's say we got these 3 forward slashes there. We could be whatever, but we don't know. And we want to print, let's say this is unsafe. This won't happen, but I don't know how even you would make this happen, because this is only because it's in an interactive console. But yes, we could put that, press enter, and we're using commas inside a string. Yes, we have that, and we print enter. We press enter. Will it print that? No. But if, yeah, that's just printed, but it's like if it's not there, it's only printed on the console, but it's not as input for the Python interpreter. Okay, so let's go back. What is the ASCII character for a new line? ASCII, let's say, what is an end of line character? And it is a character in a string which represents a line break, which means that after this character a new line will start. There are 2 basic new line characters. Ere, this is the character N. Character ASCII 10. So ASCII 10. Oh, yes, it did. It was the 10, not the 11. So it went forward, and this, which it printed, is the 4. So it printed 10. Okay, so this prints hello world and then a carriage return. Let's see. There's, I don't know if I can put as input a carriage return. Let's see. 913. Let's drink some water. Let's go back to our echo program. Copy this. And yes, we got hello world, and we want a new line character. Let's see if it's going to save that. No, it just get that. Can we copy? Well, I don't know how would I input a new line character to here? Because I cannot copy and paste it from elsewhere. Let's see. Can I? This I should have copied. Yes. There it is, a new line. And we run. And yes, we got a new line character. Okay. So we printed hello world in 3 different ways with BrainF. I think that is enough esoteric programming for today. So goodbye.